Hello YouTube, it's Troy again, and welcome back to the channel of The Lonely Wolf. So today we're going to be doing a discussion on multiplication. So it's a variety of methods. So I'm going to run through the old and the new method, or as some people say, the Common Core. Now, when I say the word Common Core, it does evoke a lot of, I guess, controversy and debates about what's the best method of teaching. Now, really, my aim and my audience are mostly towards parents. So it could be people who are doing homeschooling. So, if you're a homeschooling parent, then this is the right video for you if you want to know more about multiplication. And it would also be appropriate for you to actually have your student join in and they could actually watch the video. So it's something you could do together and it could promote a bit of discussion about mathematics. Okay, so we're really looking at old methods versus new methods. Now, really, my intent here is not really to be critical or to say which method is good, which method is bad. I'm going to try to be as objective as I can. Now, the reason why is because it is what it is. Okay, so some teachers are going to be teaching these particular methods of multiplication. Okay, so some schools are going to have that as part of their curriculum. So that's not something that's really in my control. The only thing that is in my control is to really help bridge the gap between all these different methods. So really my intent is, I guess, to alleviate some of the frustration that a lot of parents have when they're trying to help their students with their homework, or they could be homeschooling and trying to get through methods. Okay. Now the biggest problem there is not so much the choice of method or the difference between methods. It's really the communication that's happened between the school and the student. And I feel that parents have really been left out of the equation. So that's really why I make a lot of those videos to provide that bridge, because unfortunately parents do often get left out. And in an ideal world, I think that if a school was using different methods, then perhaps they could invite and engage the parents a little bit more. So they could invite them in for workshops where they actually discuss these new methods and, maybe get parents on board so that they can communicate with their children a lot more effectively. Or it could also be newsletters sent home. So there could be articles or instructions, taken home, with the students so that parents can see what's going on. So I think it's a lack of transparency that's the biggest problem. Okay, so I think when parents and students, they're on the same page, that seems to be when the most learning seems to occur. So that's pretty much what my role is to try to bridge that gap. And so I'm going to be going through these methods and discussing those. Now, one of the foundations of my teaching, so my biggest philosophy is that I'm not really here to give you steps to say step number one, step number two. Now, I will do steps, but my biggest philosophy is looking at the mathematical foundations. So I'm looking at why we do things rather than this is what we're doing. So even though you're probably used to multiplication algorithms, so you may be used to the multiplication, the old method, but you've probably not really stop to think of why you're doing that so that you can have that discussion with students, because I think that we learn better when we understand why we're doing it and what the purpose is. So let's have a dive and let's have a discussion of three methods. So these are the three methods that I've seen the most often. Let's compare, let's contrast, let's discuss. Before I really get into this, and this is something that you're going to have to discuss with your student as well, or that students are going to have to reckon with themselves, is some of the mathematical foundations. Now, these are things that I often have to reteach when I've got students who come to me with these particular problems. And it seems to be the place value, the lack of understanding of place value seems to be a big stumbling block. So I think we really need to have a conversation about this. Now, when we talk about place value, I think a good idea is to have a place value chart if you're doing a lot of multiplication. So perhaps in the student's book, it could be on the table, it could be a poster on a wall. So you can print those out for free on anything. You just have to Google search a place value chart. So as long as we have an awareness of where numbers are on the place value. So for example, if it's a 3-digit number, so 3-digit numbers, we know that it has 100 there, we know that it has a 10, and we know that it has a 1 component. So there's 3 components of a 3-digit number. The other thing I want people to be familiar with, and this is something that I've encountered students who go straight to their calculator when they're given large numbers. So let's say it's a question like this. So I'll get my pen out. So let's say I go 3 times 200. So people automatically think, oh, but that's a large number, so therefore I need to have a calculator. No. I always say to a lot of students, start with the non-zero numbers. So you really have 3 times 2. We write down the answer, we get 6. And then I instruct students to count the number of zeros that are in the whole equation. So the number of zeros is 2. So you got 2 zeros, so therefore the answer is 600. So that type of thinking, it avoids us going straight to the calculator. Now, especially in a question like that, so let's say that it's 300 times 60. This is another example where students want to go straight for the calculator without thinking it through. But let's break it down. So start with a 3 and the 6. So I often ask students, what is 3 times 6? So if they know their times tables well, or they can look up the tables themselves, they can get 18. And then the next question I ask is, how many zeros are in the whole equation? Now we have 2 zeros in the first part, and we have 1 zero in the next part. As I said, so that gives us a total of 3 decimal places. So because there's 3 zeros, we put them in. So the answer is 18,000. So as you'll see, when I move on with some of these explanations, this is probably one of the foundational things that you'll need to understand in order to do the multiplication and understand the multiplication that we're looking at. Before I go through the nuts and bolts, the explanation, I'll give you time to appreciate this meme. So I think that a lot of parents can relate to this one, and grandparents as well for that matter. So during the COVID lockdown, I think that parents were seeing more of their students, so they had a bit more of a role and they could see what was going on in the classroom and what their students were learning. And then that often sparks a lot of debate in the household, a lot of tension, a lot of arguments between parents and children. So I'm sure you can appreciate this meme if you're in that position there. So I'm actually going through this method. So this is the traditional method, and that's where the way a lot of parents, a lot of grandparents will understand multiplication. The only thing I really want to add is that, yes, I think a lot of parents and grandparents, you will know how to do this. So you'll know the steps and it's in your muscle memory. The one thing that I encourage a lot of parents to do, especially if they're supporting their students, is to go back to the fundamentals and remind yourself of why we're doing these things. Okay, so try not to think of it as a mechanical list of steps because that's going to be in your muscle memory, but look at the reason why we're doing those things. So I'm just going to have a bit of a spiel about what's going on. So the basis of our multiplication is we're going 36 and we're timesing by 43. So that's how it gets set out. So a lot of people understand we go 3 times 6 and 3 times 3, and then we put a 0, and then we go 4 times 6 and then 4 times 3. Okay, that's what we understand. So why do we do it that way? That relies on the fact that we're understanding place value. So I'm going to come back to place value. So 30. So 30 is split up into the tens part, which is the 30 plus a 6. And that is being multiplied by 43. Now, if we tease that out, we end up with 30 times 43, and we also get 6 times 43 as well. Now, the good thing about this is that it really gets us back to the distributive law, and that trains students for algebra, but you wouldn't have to write this down. Okay, this is not to write down. This is just a discussion space where we can think about what we're doing. Okay, so that really explains what we're doing. So my first line is multiplying by 6. Okay, so 43 times 6. So let's do that part. Okay, so you've got 3 times 6 is equal to 18, and 3 times 3 is equal to 9, plus 1 is giving 10. Okay, so that takes care of this part here. We've multiplied by 6. So the next part here is the 30 times 43. So this is the reason why we're putting a 0 down here, because we're multiplying 4 by 6 and we're multiplying 4 by 3. Okay. Now, the reason why we've got that extra 0 is because we're multiplying by 30. Okay, so 30 is the key number. So we're now in the tens house, and that's why we have to put an extra 0 there. So let's do the work here. So 4 times 6 is going to be equal to 24, and the 2 is up there. 3 times 4 is equal to 12, plus 2 is going to be equal to 14. Okay, so we all know the next step is adding those up. And why do we add those up? It's because the foundation, it shows us that we have to add up these two numbers. So that's why we're adding up the columns. So try to remind yourself of why you're doing something when you're doing this, or when you're trying to explain this to somebody else. All right, so we get 8, 4, 1 plus 4 is equal to 5. and 1. Okay, so the answer is 1,548. And I checked it on my calculator because I don't want to give you the wrong answer. And lo and behold, we're correct. So far we should be on the same page. The only thing I want you to remember is to think about the why. Okay, so I want you to think about what I've written on the right-hand side and think about it a little bit. Grid multiplication. So this is where people are going to start getting a bit defensive, and I admit I only learnt this over the last 5 years or so. So the reason is because it's something that I see. Okay, so I know that it causes a lot of frustration for parents, grandparents, especially with homework. Okay, so I think, as I said before, I think it should really come down to the schools and the teachers. I wish there was a bit more engagement with the parents. So an attempt to reach out and to try to, I guess, demystify all these things, because this looks really strange to somebody who's never seen it before. But as I said before, I'm not really here to criticize because it is what it is, but I am here to try to demystify it and to try to give you the mathematical foundations to do that. I guess the why is an important thing as well. So this goes down to 36 times 43. So I'm going to give you a little bit of a spiel here. Now, this doesn't have to be part of the working out. Okay, this is just a talking space that we're doing here. So what we do is we break up our two numbers. So 36 is broken up into 30 plus 6. Now 43 is being broken up again. So that's 40 plus 3. And so what that results in is we've got three multiplications going on. Oh, sorry, four of them going on. Okay, so we got 30 times 40 is the first one. You also have 30 times 3. You also have 6 times 40. And you have 6 times 3. So that explains why we're going to have four different grids. Now, as I said before, this is not part of the working out. It doesn't have to be. This is just an explanation space. Now, what we do as part of the working out is we start with 36. So I'm going to put a 30 and a 6, and then a 40 and a 3. And what we're going to be doing is multiplying with each of those grids. And that's why we have four different entries, because of the explanation we have down here. So the first one is 40 times 30. So we know that 3 times 4 is equal to 12. And we know that there are two zeros. So there's one for 40 and one for 30. So therefore we have two zeros. So see how the place value always comes back into our equation. It's something that we always keep revisiting. Now the next one is 40 times 6, and that should give 24, but we have a zero next to it, so it's 240. So 3 times 30, 3 times 3 is 9 with our 0. 3 times 6 is equal to 18. Now, as we said before, what are we going to do with those numbers in the square? We're going to add them up together. So let's do that together. So 1200, and then 240, and then 90, and then 18. So this is good practice at lining up all your decimal places or lining up the digits. Okay, so our first number should be an 8. So our second number is 4 plus 9 is 13 plus 1 is 14. Carry the 1. So 1 plus 2 is 3 plus 2 is equal to 5. And then we've got our 1 that goes down there. And so lo and behold, we got the same answer as before. So hopefully this is an explanation of how we do it and then why we do it. So it's a good thing to have a discussion with your students saying, okay, you've seen these methods, which one do you like better? And I guess you'll discover. So you might be surprised. You might disagree with each other, but it's a healthy conversation we can have. This one is going to stir a lot of feathers. So when I first saw this, it was very confusing. And that's really, for a parent to see this or an adult to see this, it's really quite confronting, because you think, well, this makes absolutely no sense. I can't see what on earth is going on here. So it does require a lot of explanations. And as I said before, it would be a good thing to have, I guess, to engage parents to sort of show them these methods from step one. So just a simple instruction, and then to also look at the mathematical foundations. So this is probably one, it's probably not my favorite one. The only time that I'd ever like this one is if it was a large string of numbers where the other methods might get a bit too much. But then, we also have our calculator if they're, really large numbers. Okay, so I'm going to go through the lattice method step by step. So in case you haven't seen it before. So 36 times 43. So because they're both 2-digit numbers, we're going to set up a 2 by 2 grid to make 4 squares. So the next thing we're going to do is add on diagonal lines. And that's why we call it a lattice method, because it creates a lattice-like pattern. So that's what we do all the time. Now, the next step that we do is we put in the numbers. Okay, so our first one is 36. We're going to put a 3 on the first and a 6 on the second. Now, what we're going to do is the bottom right-hand side, we're going to put the second number. So the second number is 43. We're going to put a 4 and a 3. Now, what we're going to do is fill in the inside of the lattices. So this is the one where it looks a bit confusing, but it's not really too bad. Okay, so let's have a look. Okay, so I'm going to start with the first. So I'm going to use a bit of a highlighter so that we can know where we are in our first one. So our first particular grid we have to fill in, it's 3 times 4. Okay, so we have a 3 up there and a 4 up there. So 3 times 4 is equal to 12. So you write the digit like this, 1 and a 2. So the first digit goes on the left-hand side and the second digit goes on the right-hand side. Okay, let's do our next one. So I'll highlight as we go along. So our second box, oh, let's use a yellow. Okay, that wasn't a good thing. I'm really going to mess this up, aren't I? Okay, let's do it. Okay, sorry about that. And let's go back to pen. So I'll make sure I choose a good color. So I'll choose a dark blue. So 6 times 4 is 24. So we write 24. So first digit on the left-hand side, bottom digit on the right-hand bottom. And let's fill in the other two. So this next box here, okay, the lower left-hand corner, that's going to be 3 times 3. And so 3 times 3 is equal to 9. So what we do is write it as a 0 and a 9 if it's a 1-digit number. And the last one we're doing, the bottom right-hand corner, is 6 times 3 is equal to 18. Okay, so that was the most of the work is out of the way. The next step is actually an addition step. So what we're going to be doing is we're actually going to be adding up the diagonals. So my first diagonal is this one here, it's 8. So the answer is going to be 8 in here. Now the reason why it's here, you'll see that in a moment. Okay, so our next one we add up is 4 plus 1 plus 9. Okay, so we're adding up our next diagonal. So 4 plus 1 is 5, plus 9 is 14. So we're going to put a 4 down here. And then our next diagonal, we'll have to carry the extra 1. Okay, so 2 plus 1 is 3, and 2 is going to make 5. Now our last diagonal is this one here. And that's just a 1 there. And we got the same thing because I'm using the same numbers. So our answer is 1,548. Okay, so let's try to look at the foundations of that. So why does it work that way? Why do we do it this way? Why did we invent this method? Okay, so first of all, we have to understand the place value. So if I look at this particular square here, okay, so this one is 3 times 6. So the 3's and the 6 are both in the units column. So that's why I get 3 times 6 is 18. So that's why the 8 is going to be in the units column. Now, if I go for my next one, I'm going to go 6 times 4. Now, it's not really 6 times 4, but it's 6 times 40. So that's why we're going to start getting numbers that are in the hundreds. So we're going to start moving this way. So we start with the units, and then the tens, and then the hundreds, and then the thousands. Okay, so it works kind of similar to the grid method, but it's probably more appropriate for the larger numbers. So you'll see why when I do another example. Okay, so this one's a larger example. So this method is kind of okay for me if we're dealing with these type of numbers here, because the old method, I still probably would use it, but there's a lot of crossing out of numbers and it would probably get messy for me. So we'll do the same thing. So 789. So we're going to put a 7, an 8, and a 9. Then for 461, we're going to put a 4, a 6, and a 1. And the lattice has already been prepared for us, so pre-prepared. Okay, but you should know how to draw the diagonal lines like that. Okay, so what I'll do is the highlighter. So I'll try to get it right this time. So we'll start with our first thing here. Okay, so this square here, look at the numbers that are there. So it's going to start off with 9 times 1. Okay, so 9 times 1 is going to be equal to 9. So remember we put a 0 and a 9. Okay, so what you're going to have is in the units column, you're going to have a 9. Okay, that's because the 1 is in the units and the 9 is in the units. So that's why it's going to be on this end of the thing. Okay, so let's do the next one. So we'll fill in this square here. So this one is going to be 9 times 4, but to be more, 9 times 6, my bad. Okay, so 9 times 6 is equal to 54. Okay, so the next one is going to be the one above it is going to be 9 times 4 gives 36. So it's really not that hard, is it? You just have to multiply and then just put the numbers in their places. Okay, so let's move up to the top middle. So we can have 8 times 4, and so 8 times 4 is equal to 32. So this box here, okay, so it's going to be 8 times 6 is equal to 48. And the last one is 8 times 1, and that's equal to 8, but we put a 0 and an 8 there. And let's look at our last row. So 7 times 4. Okay, so remember, we're really doing 700 times 400. So that's why our numbers are all the way up here into these larger, larger place values. So 7 times 4 is 28. 7 times 6 is equal to 42. And 7 times 1 is equal to 7. Let me put it at 0, 7. All right, so hopefully we're good. So let's do the adding up. Okay, so as I said before, we do it by diagonals. Okay, so our first one is going to be a 9. Our second one is going to be 4 plus 8 is equal to 12. So we'll put the 2 down here, and the 1 goes up to our next diagonal. So 6 plus 1 is 7, 8, 9, 10, 11, 12, 27. I had to do some finger counting before then. Okay, so 2 plus 3 is 5, plus 2 is 7. So that should be 13. Okay, so that number there, adding up all of these gave 13. So I'll just actually draw you a diagram like this. That might help you out a little bit more. Okay, make sure we put a 1 up there. So 1 plus 3 is 4, and 4 plus 8 is 12, and 12 plus 4 is 16. And 2 times 1 is equal, 1 plus 2 is equal to 3. Okay, so the answer, so what we do is start off with the units. This is the units, this is the tens, this is the hundreds, the thousands, okay, the 10,000s, etc. Okay, so the answer is going to be 363,729. Okay, so easy once you get used to it. Now, as for your opinions, okay, maybe you can leave something in the comment below. So which method do you like the best? So do you think the Common Core is a terrible thing? So it's really, I guess I'm open to anyone's opinion. Now, personally, I'm not really here to pass judgment on any particular method. I think my philosophy, the one thing that I'm about is about understanding the why of doing something. So I think that the concept that I really want to dig home and the take home that I really want you to get away from this video is that the place value is one of the most important concepts. So it underlies multiplication. So rather than just going through an algorithm, try to understand the reasoning behind why things are the way they are. And that really helps you to understand, and it really keeps it in your memory. And then after a while, it should become into your muscle memory. And then we can put it into problem solving applications. Anyway, that's me done for this lesson. So this is my third attempt to record. So that's how hard it is to do these recordings. So I'll see you in my next video. So hopefully another music video. And so keep on learning. So good luck, and I'll see you next time.